All right, hey, welcome to Unit 10 Learning Target. I can compare, or I can graph quadratic functions. So this is the third lesson in this. In this lesson, it's a review, getting ready for that test. So I'm going to break down each learning target. So this first one is I can compare functions. So thinking in class, just like we did, we have the three types of graphs that we've seen throughout this year. So we've got linear, exponential, and quadratic. So in class we talked about what those should look like. Hopefully, looking at these three graphs here, 1, 2, 3, and these three equations, you can identify which is which. So the first part of the learning target just has you say which one is exponential, which one's quadratic, and which one's linear. So feel free to do that on this problem. Let's check it in class. But then I want to look at some more information because the rest of it is matching and kind of a breakdown of what we did in class. So as we look at the equation, y equals mx plus b. Okay, a linear equation. So what are the important pieces here? This linear equation, I'm looking at the m, the slope determines if the line is increasing or decreasing or even stays the same. Okay, so remember this is our positive slope and this is our negative slope. Okay, the b is the y-intercept. So you will see that on the y-axis. So it would be somewhere along this line, not necessarily positive, but somewhere along that line. Okay, then taking a look at our next equation, exponential. Sorry about that, interrupted. Y equals a times b to the x. I know we talked in class about how that a is the y-intercept, how b determines if it's growth or decay. But just a quick reminder of what those might look like. So perhaps you have an equation like y equals 3 times a half to the x. So something like this is going to have a b of 3 and decaying. So it's going to look something like this. The y-intercept is 3 and it's decreasing, as opposed to y equals, let's say we have 2 times 3 to the x. So the y-intercept here is going to be 1, 2, and it's increasing. So it's going to grow because that b value is greater than 1. Okay. And then being able to match the quadratic. Well, that's what we're going to do in the next couple slides. So here I can graph quadratic functions. That's the second learning target on this test, or maybe the third. But I hope, based on what we've done in class, that important information you can come up with. the line of symmetry, the vertex, the x-intercepts, the y-intercepts, and in whatever order, and if it's a max or minimum. So try this out. Remember for the factoring, factor out that -2 when you have to get to the x-intercept part. Okay, try to find all of this information. So this we've spent quite a bit of time on. If you need more help with this, make sure you come and get that help. But I want to focus on the next learning target. So the final learning target is I can understand quadratic transformations. So all of these are comparing with the graph y equals x squared, which is that parent graph. The y equals x squared graph I talked about has a vertex at the origin. It goes over one and up one on both sides, and then kind of graphs through that, making that regular parabolic motion, that U shape. Okay, the line of symmetry goes straight through there. So anytime you're asked on the test to compare, we're talking about if it's up or down, so concave up or down, so that's based on the A value in front. If it's wider, narrower, or normal, shifted up, down, or at the origin. Okay, so this one's at the origin. But if we take a look at y equals 3x squared minus 2. So we talked in class about, hey, the A value, A is 3. Okay, so it's a positive, so it's going to open up, concave up. Okay, wider, narrower, or normal. Okay, normal has that A of 1 right up here, 1. So since 3 is bigger than 1, it's going to be narrower, which is contrary to what we want to say. But because every value is getting multiplied by 3, it's going to be tighter, okay? And this -2 here, that shifts the whole thing. This is where the vertex starts. So that's going to move it down, shifts down. If we looked at another example, y equals, let's say we have a third x squared, let's say negative a third x squared plus 1. Okay, so as we look at this, so again, looking at that A value, A is -1/3. So the negative part tells us it's concave down. Okay, the third part of that is going to tell us that it's going to be wider. And the +1 is going to shift it up. I should have put shift up over here. Shift up. Okay, we're going to practice this more in class, but I just wanted to give you that as an example in case you need it to finish the worksheet or the homework or to prepare for the test. Thank you.